Hi there, this guy's I'm making this video and maybe turn this into a series where I set up agenda uh, goals that I want to, achieve. But to kind of give you more context, I'll kind of give you a little bit glimpse of my history. So right now I've been doing Ruby on Rails extensively for the past couple of years, and I realized, uh, I mean not realized, but this quality is inherently I own it. Is that whenever I write any code, the first question that comes into my mind is it performant? Is it fast? Is it good? And the second question is it good code as in readable and maintainable? And so as I mentioned, my first priority is performance. And so Ruby is pretty good uh, language. You know, we have this popular framework that's Ruby on Rails, which is pretty good from developer experience point of view. It gets you up and running pretty quick. And so if you have any idea, any business idea that you want to implement and kind of test it out in the market, you can pick up Rails and do that pretty quick. You don't have to, develop tools and anything on your own. So this has philosophy as a configuration, convention over configuration, right? That is, they define set of rules for doing certain things, and you cannot follow those. You take their experience, and which is good. Like this is the reason it's popular in the startup ecosystem. And I like writing Ruby code. It has oops, is oops language, and oops is from a philosophical point of view, it is excellent. It's amazing. I really like it. But from a performance point of view, Ruby isn't that great, right? Ruby has global, what's it called? Global interpreter lock, yes, which doesn't let it execute code parallelly, right? More on that later. But first, I would explain, not explain, give you more about like what I did. So I got, because of this performance, I started looking into different languages. So I gonna learn some Haskell, which is pretty amazing, but it was like over the head, and then some Rust, and I've done some Go as well. I've written uh, uh, HTTP HTTP server in Go, which is I mean basic. We are coding crafters or code crafters. So Go is pretty amazing as well, closer to machine, closer to hardware. But one language that stood up to me was Elixir. It's amazing. Let me tell you why. Elixir is like Kotlin in Java ecosystem, right? So in the telecommunication industry, there was this uh, uh, programming language as Erlang, and Erlang they have developed this Beam VM. It's like JVM, and it's amazing. It is fault tolerant. It is parallel, and it has it's kind of battle tested in telecom sector. Telecom sector, as you might know, it's all about scale. It's fault tolerance, reliability, and as they say that we have the same thing going on with web, right? We have concurrent connections, we have web sockets, uh, right? Internet is fast, it's data intensive right now, right? So Elixir is amazing, right? To me, to my mind, and in reality, it is as well, right? So to kind of explain this more, I would explain what's the difference between running programs concurrently and running them in parallel, like parallelism and concurrency, right? So if we have any set of process or threads, anything, any piece of code that we can execute in isolation or independently, let's imagine we have three processes or threads, P1, P2, P3, and we have only single core or single CPU. So what we do is we can switch, context switch between these three processor set of piece of codes such in such a manner that to the end user it looks they are running in parallel, they are running side by side, but that's not the case. You can imagine the simplest example would be if you're using a browser, a calculator, or maybe some music app, right? So what the CPU does is kind of takes this process, gives it some time, let's say 10 picoseconds or maybe 1 milliseconds or maybe 1 second. That would be yeah, huge. But can I give this process a time, this some time slice, and there's a simpler algorithm that's round robin that is taking a set of processes and giving each CPU in a round robin fashion. That is one we pick this, then pick this, then pick this, and we give them equal time, and then we come back to the first process until or executed or like some are executed earlier, finished execution. But you might say, I don't feel jitter in the music. My browser doesn't stop working, right? My calculator is working fine. I don't feel like, because I feel like, they are working in parallel, but that's not the case. And thanks to the speed and scale of these processors, they are executing billions of operations per second in one cycle. It's amazing. I can, to be honest, I can never comprehend that. I cannot count billions of operations or billions of instructions in one go. That's crazy scale, right? And these processors are getting powerful every day, right? Uh, so we have one core, it's extremely wicked fast, and we are kind of running these programs concurrently. It is giving the illusion to us that they are running side by side, which works great. And this has been the model for the history, right? But lately, over the past decade or so or more, we have been developing processors that are multi-core. That is, we can run code independently. Now, here in this model, we had built a different language and different tools, and that were built around this mental model that is running code on one CPU. And Ruby is kind of one example of that. Ruby executes code in one process, right? And that's the reason it has been developed in such a manner that we had to, you know, uh, implement a log pair, not to execute threads concurrently, sorry, in parallel, because it creates data race conditions because of the language design, right? Coming back to parallelism, as you might already guess, if we have three processes, Sam. So before, if we see the timing diagram of these three processes, so we have, let's say, a graph. We have three processes, and if we imagine each process takes 1 second, then these three processes would take 3 seconds, right? This takes 1 second, this takes 1 second, right? And here, let me just erase it. What the heck? This should not happen. Okay. Maybe I can do this. Where is it erasing? Yeah, works. So we have, if we have three processes, what we do is we run these three processes in isolation independently. Doesn't matter isolation. I mean, I don't know, like maybe they share memory, but yeah. So we run these process or sort of code on each core, right? Or maybe each processor, right? So if we see the timing diagram of this, we have three processes and each takes 1 second. So all these three processes take only 1 second. That's cumulative time. So isn't this amazing? To my mind, it is. And Elixir and Beam VM is amazing at it, right? Coming from the telecommunication, right? Beam VM has, on Beam VM, we can create millions of, maybe billions, depends on the configuration of the machine. We can create so many, lightweight Beam processes on, this VM, and we can execute them concurrently and wouldn't have to care about data races. I mean, we have to care about, but it mostly allows, this scale and writing code in this manner, and which is amazing, right? So now I have three goals. I will point them out. So first, I started from Elixir, right? And then now Elixir is a functional language, right? So I come from OOPS. I have developed this mental model, OOPS mental model. And whenever I see a problem, solutions instinctively come to my mind that are imperative, that are procedural, like a set of code that we execute or mutate. That I mean, that's my mental model, right? And Elixir is functional, so it kind of uh, beats my instinct to problem solving. Uh, so I have added functional mental model, functional programming mental model now. I want to develop this thinking model so that whenever I see a problem, I would be able to easily kind of translate it into functional code. That is Elixir functional. These are two things. And third thing is maybe get good at algorithms, right? So I'm pretty average at algorithms. So yeah, I would be writing algorithms in functional manner so that we have these things. We learn this is all for learning purpose, right? And it's majorly for myself and maybe you as well. So if it interests you, this set of goals, then I would recommend subscribing. I don't know, maybe I'll turn into a YouTuber. Okay, see you around. And yeah, one more thing here. So since I would be going with algorithms, I would take simplest, sorting algorithms first, and everybody knows which is the simplest. That is bubble sort. It's not bullshit, sorry, bubble sort. So this is the first sorting algorithm that I learned when I was doing my bachelor. So yeah, I would start with that. So see you around with bubble sort.